And so it is. Welcome to Auth Part 2. By the end of this lesson, you should be able to verify a user's identity in Rails. You should be able to issue signed tokens to users. And maybe, might not get to this one, you might differentiate between authorization and authentication. So, first thing that we need to do is everything from step 1. Hopefully you remember how to do it. So I'm going to put 6 minutes on the clock. Let's all do well, I guess it doesn't really matter today. We're going to call this FarmTown. You're going to make an API called FarmTown that creates users with hashed passwords. So 6 minutes to make the FarmTown API. Go. We're going to go back over it when you're done, so don't get too bummed out if you're missing a step. 6 minutes. There's the steps up in the corner in case you forgot. Two minutes? And time. All right, so I want to see a fist to 5. Fist is what we're supposed to be doing. 5 is I got it done. How did that go for you? Throw them up, hold them up. Good, 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 good. All right, cool. So let's go through the steps on this. All right, so we're calling this one Farmtown. Rails new -- API Farmtown. All right, we head over to Farmtown. We want to install bcrypt. So to install bcrypt, go to the gem file, uncomment out the line, and then bundle install. All right, cool. Bcrypt is installed. Want to create a route to create a user. So we're going to do resources, users, but solamente create. Okay, very nice. Now we want to create a controller to create a user. So we Rails G controller users. And then we go over to that users controller. We make a create method. User.create, take in a username. This is your periodic reminder that it doesn't have to just be username and password. In fact, technically speaking, you don't even need the username. We could do everything by ID if we wanted to. We could throw ages. It's just a Rails model. We can do whatever else we want on it too. We're going to render JSON. Send it back. Let's go ahead and send it with a status as well. And awesome. This controller looks pretty good to me. Then we want a user model with a secure password. So we Rails G model user. Go over to the model, has secure password. It's a macro, just like adder reader, adder writer, adder accessor, all those, same kind of thing. Then the migration, we're going to store username as a string, and then we're going to store password as what?
Password digest.
Password digest, thank you. Very nice. So, if I Rails DB migrate, and I Rails S, and I throw open Postman. Oops, I opened the old one. It looked like the new one, though. So I go to localhost 3000/users, and I send username Kyle, password Kyle over as a JSON string. Pew, 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 201 status created. I do not see my password back. What is this? It's not my password, it's a
Hash.
hash. Cool. What's a hash? Who can give me, I want volunteers for this one. Throw up a hand on your screen if you can answer me what a hash is. Austin.
It's like a one-way function, and if it's provided a properly designed algorithm, then there's really no way to like reverse it and steal their password information.
Exactly. If you steal my password hash, you really don't have anything all that valuable. Because what you need is not the hash, you need something else that generates that hash, and that's a tricky one to decipher. Cool. Before we go into the next part of this, we're going to do two things. One, if you got yours up and working and you're happy with it, make a commit right here. So we're going to add all of that, and we're going to commit that as like step 1.
So mine doesn't work.
Okay, that's the next part of this. So if yours doesn't work, I'm just going to give you one. You can use mine. So this is going to be called Farmtown API. Origin. Oops, got it backwards. Get remote. Add origin. Get push. Origin master. All right, so this repo, if you want to pull something down and follow along off of this, is that. Cool. So before we go to this next step, I want to talk about a weakness in hashing real quick. So you cannot realistically reverse a hash into a password. That doesn't mean that all hashes are equally secure, though. Can anybody think, you steal Home Depot's database, you have a bunch of hashed passwords, unless they took an extra precaution, you could still probably guess an awful lot of the passwords. Let's say most common passwords. People's doing password 123, that kind of stuff. You probably still got them. Can anybody guess why?
Because if an algorithm created it, an algorithm can uncreate it.
It's not uncreate it necessarily, but the algorithm created it. It can reliably create that, and that's the problem. The particular kind of attack I'm thinking of is called a frequency attack. And it's using that in a statistical sense, like a distribution of frequencies. Some stuff occurs really often. Oh my God, what the fuck is that? Shut up. Some stuff occurs really often, some stuff happens less often, and we can take advantage of that fact to get some of the more common passwords. Anybody got it yet? If my password is cat, let's say even have, or fuck, it's Kyle. So my password here is Kyle, and I get this awesome hash. Neat. What if your password is Kyle? What hash do you get?
Same hash.
You get the same one?
Same one. Uh-oh. Anybody see the attack vector yet?
If you can figure out one, you can figure out many more.
Yep. And what would aid you in figuring out what one of them is? Remember, think about that frequency distribution.
Find the most common one and then reference it to a bunch of words.
Exactly.
If somebody makes a shitty password.
Also, you can just reference it directly to a list of commonly used passwords.
Right.
Yeah, because it's probably going to have about the same shape to it. That's what makes them common.
And that's why people won't let you make a shitty password?
Yes, that's one of the reasons that they would do that. But we have an even better solution to this that doesn't make our users change our behavior. Any security thing that relies on your users changing their behavior is not going to happen. So we have a tech solution to this that's even better than that. Pull up a whiteboard real quick.
May sound weird, but could you do it twice?
Could you
That's
hash
what I
it
was thinking.
twice? So if you hash it twice, you hash Kyle, and you get this. And then you hash that again, and you get a totally different thing, which would also be the case with anybody else's. Remember, you're not comparing it to like somebody else's password database. You're comparing it to how common a used password is. If it's a randomly generated password, none of that works. But if you allow password 123 and you allow stuff like that, kind of a different story. All right, so our solution to this is a thing called SALT. Again, this is a kitchen reference. It's not like a math term or something. You know what? Maybe me and Miro need to break up. I don't know if I like this whiteboarding tool anymore. Okay, so I have cat, and it hashes to something secure. Neat. But if you have cat, it hashes to the exact same thing. So what we really need is something we can add on to the end of cat that would make it hash to something completely different. So if I have cat 2, well, then I get a wildly different thing. And if you have cat 3, you get an even weirder thing than that. Things that are close don't have close hashes. You can't tell that something was one character off because their hashes are really similar. It doesn't work that way. But the goal of this is that we're trying to not make our users change their behavior. So instead of having them add random characters to the end of their password, we can do it for them. They give us a password, we add a random string of characters to the end of it, and then hash that. And here's the cool part about this. Those random things that we're adding on the end, we can store those in plain text. Who gives a shit? In fact, we can store it in the hash itself. This password digest right here, there's a couple special characters in here. You'll notice that these first ones are always the same. $2A means you're using the second edition of this algorithm. 12 is what's called the cost. It's essentially how many times you hashed it. And then the first few characters, I think it's the first 6 characters or something of this, are randomly generated salt. We add those to whatever plain string we have, and when we hash it, we get the rest of it. And then we store it all as one big long thing. Isn't that fucking cool?
Couldn't someone, like if they had access to the database, couldn't they make an account, do something that looks like unique as that account to reference that data, and then they know their own password so they could reverse engineer the hash, right?
So part of it is that they're not reversible. Even if you had all those things, you're not any closer to like getting anybody else's password. And generally speaking, I know we're doing this in this exercise, but you don't send back the user's hash password to them. Even a user doesn't even know what their hash password is.
Oh, I was just saying somebody who has access to the database and could see all the hashes,
Sure.
they could put in some other information that like uniquely identifies that that's their account, and then they have their own password in it.
Well, here's the coolest part about this. That would help them figure out what the algorithm was that generates the hash.
Right.
Everybody knows how the bcrypt algorithm works.
Right.
It's that the extra pieces are randomly generated. That's what makes it secure. Now, what you could do is go, okay, so password 123 plus this salt generates this hash. And password 123 plus this salt generates this hash. That's called a rainbow attack. You can still do that. That is many orders of magnitude harder than a frequency attack. At some point, like there literally has not been enough storage space created on hard drives to track all of the different possible permutations of that. Other questions about hashing and salting? Cool. So let's dig in. Our goal, we have steps for this also. We want to create a login route. We want to create a login controller and action. We want to look a user up. We want to authenticate them. And then we're going to create a token and send it back to them. So just like yesterday, I'm going to do these things. You're going to watch. Don't worry about following along. You'll get a chance for that in a sec. You can take notes if you want, but otherwise don't try to code along. So creating a login route. What we're going to do for this, so you're going to go over to our router. And this is not a resource. A resource is like a model that we can take actions on. We can create them, we can delete them, we can read them, we can do stuff like that. Login is an action. Like it's not one of those things. The technical term for this is RPC, or remote procedure call, but don't worry too much about that. What you need to know is that we don't get to use the short form of the route for this. We actually do want to use the long form. So we'll say when you get a post request to login, send that to the authentication controller's login action. So any HTTP request that has a post method and a login path should get sent to the login action on the authentication controller. That's how that works. Then we want a login controller in action. Cool. So if this is going to an authentication controller, then we want to make an authentication controller. Rails G authentication. Oh, crap. Rails G controller authentication. Cool. It is so. Then we're going to go over to that controller we just made and make a login action. So again, A request that looks like this goes to this method on this controller. That's that method on that controller. All right, doing good so far. Next step is we want to look up a user. So let's say they're sending us a username. So I want to say that a user is user.find. But find is always looking for an ID. So if I want to look somebody up by username, what's the active record method for that?
Find.
Nope, find is ID only.
Oh, find by.
Find by. Find by will let you look up by any field you want, even combinations of fields. So we're going to look for username is params username. All right, so that gives us a user. What if we put a username in that doesn't exist? What does that mean?
And that object would be null.
That object would be null. That means it wouldn't pass a conditional check, that's for sure. So if we don't have a user, but what does that mean semantically?
They need to create a user account.
Potentially, or they fat fingered it or whatever. But it means it's an invalid username. So we can just tell them that. Render JSON, give them like error, add username. And then we can give that a status of 401. Or no, 401 is unauthorized. Okay, cool. So with just this, like, we should be able to do something. We could even put this here. So with nothing else, I should be able to send my Kyle account that I created and see whether or not the username is right. So when I say, cool, post to users, I made the account. If I post to login with the exact same stuff. Oops, I got to run the server. That helps. All right, I got good username. If I make it Kyler, bad username. All right, so logic works so far. So that is looking up a user. All right, next thing, if I need to authenticate them. This is the second magical thing we got from installing bcrypt. We got has secure password, which turns password into password digest and all that kind of shit. The other thing is we get an authenticate method on that model. So if the username is good, then the next thing that I want to check is if @user.authenticate. So if that doesn't work, what does that mean?
If that's returning true, I would assume that their authentication was successful.
Yep, and if it returns false, what specifically didn't match?
The password.
The password. So it's doing all of the like heavy lifting of taking the password, adding the salt to it, hashing it, comparing it to the one that we have in the database. That's what that .authenticate method is doing. We get all of it for free. And if that doesn't work, it means their password was wrong. So couldn't find the user, must be a bad username. Couldn't find the, couldn't authenticate, that probably means that they didn't enter the right password. So let's see if this works. If I, let's see, Rails S, all right, so I do that, I get bad username. If I enter everything correctly, oops, someone I didn't like. Wrong, oh, actually, one other thing that we need to do on that. How does it know what we want to authenticate?
We have to provide it.
Yeah, we have to like give it a password to authenticate with. So we can give it params password, like that. You could wrap that in quotes if you want. All right, let's try that again. So if I do everything right, good so far. All right, what if I enter in Kyler as the password? Bad password. What if I enter Kyler as the username? No, bad username. Put everything in correctly. Good so far. All right, that's what we're talking about. So we can create a user with the password, and now we can see whether or not they gave us the right password. That's pretty powerful. The last step of this is this token piece. So what tokens do is token is evidence that you logged in successfully. So I'd send you Kyle and Kyle as my username and password. But if I like have a whole bunch of things that I need to do, like creating house listings, creating new crops for Farmtown, whatever, I would have to send that every single time. That sort of sucks. So what I can do instead is I can give you a token that I created, and I go, hey, this token is me signing a little piece of paper saying that like you logged in. Okay, just show this to me every time that you want to do something that requires you to be logged in. I'll be able to understand it. I know my handwriting. I got a special stamp. That's what a token is. It takes the place of a username and password. It has a couple other benefits too, like you can expire them. So you can make people log in on some kind of frequency. You can, this is like the danger with tokens, but also a benefit. They're portable. So if you have somebody's token, you can pretend to be them. It's the exact same thing as like having someone's username and password. But upside of that is if somebody intercepts your token, they can pretend to be you until the token expires. They would need to be able to reliably get tokens to continue to be you. All right, so to create tokens in Rails, we are going to do a couple things. First thing, we need to actually install another library, and this is called Jot. You go over to your gem file, down at the bottom, we're gonna add gem JWT. Wow, Kyle, are you having a stroke? Did you actually pronounce that Jot? I did, that's how it's pronounced. I didn't make that up. JWT is pronounced Jot. It stands for JSON Web Token, and it is a format for making these tokens. So we're going to add Jot to our gem file, and then we're going to bundle install. All right, so Jot's installed now. Now we can go over to this authentication controller, and instead of just sending back a like, yeah, it worked kind of message, we want to generate a token. There's a couple things that this needs. It needs a payload and it needs a secret. So the payload is going to be whatever kinds of things we don't want to have to look up. So like a really common thing to do, maybe you keep track of the user ID. Maybe you also keep track of their username. So we're going to put that in a payload. The next thing we need is a secret. This is a top secret key that we're going to use to, it's called signing the token. It's another hash. We'll talk about why we do this probably tomorrow. But Rails actually generates one for you automatically. It's pretty cool. And it's under rails.application.secrets .secret key base, like that. All right, so we have a thing that we want to put in a token, and we have something that's going to keep somebody from pretending they have one of our tokens. And now we're going to actually make the token with JWT, it's a class, .encode, and we're going to encode the payload with the secret. And then we can send that back. Like that. Okay, so I usually screw this up at least once when I'm working on it. Let's see if this is one of those times. So I run this server, and if I did this right, I should get a token back. Kyle, hot mama, I got a token. Now here's one of the cool things about tokens. This looks like it's hashed or encrypted or something like that. It's not. This is encoded, which is the third one of these terms that I want you guys to know. Encoded is two-way, but it's not supposed to be harder one way than the other. It's like Pig Latin. If you know one, you know the other. There's not even like really a trick to it. The reason that we do something like this is Base64 encoding. When I talk about Base64, what other bases are you familiar with? There's two of them that you use a lot.
Base 10.
Base 10. Base 10 is our decimal system. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. That's base 10. What's the other base that we use all the dang time?
Binary.
Binary. Base 2. 0, 1. That's all you got. You want to have 2? Well, that's 1, 1. So you also have done a little bit with hexadecimal. That's 16. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. That's hexadecimal. We use that for like CSS color values, some of those kinds of things. So Base64 is that exact same idea with all the lowercase letters, all the uppercase letters, and like underscore and dash, I think. 64 characters. And so we can put a really dense amount of shit and not that many characters. That's why we do it that way. So to wit, check this out. If I take that token that I got and I head over to jwt.io, which is like the JOT standard site, you can actually just paste that token in there and check it out. You can see my payload. You can see the thing that I encoded. We'll talk about it more tomorrow, but the reason that like this doesn't need to be secret is this hash. That's what the secret gave us. If you change one of these to something else, take a look at how the actual token changed when I did that. Totally different. I keep typing, that pink thing gets different every time. Also generates a completely different blue part. So if you go, all right, well, I'm not Kyle, I'm Elise. Mwahahaha. It has a different signature to it. That's a different hash. So I get that. I go, wait a minute, this hash doesn't add up. And I know that you faked a token. Cool. That's it. So we made a login route. We made a login controller in action. We looked up a user. We authenticated them. We created a token. We made this route. All post requests to the login path go to the authentication controller's login action. We made that login. And while it looks like there's a lot of code in here, there's not all that much new code, really. A lot of this is pretty simple logic. We looked up a user. If the user didn't exist, they didn't give us a good username. We called this magical.authenticate method that we got from bcrypt and gave it the password. If that came back false, we know they gave us the wrong password. If it came back anything else, then we take a payload, we take a secret, we encode it with the jot gem, and then send it back. What questions have you about this process?
So the big change you made in the controller is instead of just returning a JSON value of, you know, you entered this and this is what it hashed to, now we're making that payload object, the secret and the token, and then using those to return that to the user.
Two different controllers. We still have a user controller. We still want to be able to create users.
Okay.
After we've created a user, we want that user to be able to log in.
Gotcha.
Yeah, we didn't have to change anything from step one. Cool. Here's what I want to do. I want you to give this a shot on your own. So you can take the existing code that you did at the beginning of the lesson. You can pull it on my repo if you want, but another 6 minutes. I want you to see if you can get this part of it on your own. And then at the end of that, I'm going to do it one more time, and then we'll move on to FP. 6 minutes. Go for it. There's the steps. All right, pencils down. So I want to see another fist of 5. 1 is like not even close. And 5 is I got a signed token back. Throw them up, hold them up. Thank you, thank you, thank you, thank you. Okay, cool. So I'm gonna run through this one more time, and it's not the last time we're talking about it, so we can talk about it more tomorrow. But if I see GCO master. Okay, so starting back to the end of step 1, I create a login route. I'm going to say any post request to login goes to authentication, the authentication controller's login method. Done. Create a login controller in action. So that's an authentication controller with a login action. Rails G controller authentication. Make a login action. Look up the user. So presumably they gave me some kind of username, something like that. So I do user.findBy params username. Awesome. If I didn't find that, that means something went wrong. So I send back something that tells them that they did something wrong. And I can give them a status that indicates as much as well. All right, and then next thing, I want to check to see if their password is correct. So if @user.authenticate params password. If I can't authenticate them, it means their password didn't match the hash. So we say that's a bad password. Now, assuming both of those things check out, okay, I could find the user, password matches the hash that I have stored, then I want to create and sign a token. So I make a payload. This is the thing I want to keep in the token. This could be something like their user ID, could be their user password, or sorry, it's another password, their username. All right, and then I've got a payload. Then I might say secret. Rails gives you one for free. You can also just make one up. Anything. And then we can use the jot encode method. Also, we have to install jot. So we go over to the gem file, gem, JWT.
Could you also do like bundle add JWT?
You can also do bundle add. And like, yeah, so that totally works. And I don't know, that's a very JavaScript way to do it, by which I mean the good way to do it. No Rails person I talked to had ever heard of bundle add before. Like, no,
Okay.
you just edit the gem file manually, which sounds insane to me, but whatever. When in Rome. All right, so you add jot. That gives me this encode method. I want to encode the payload with the secret. And that is my token. If I send that back, I guess okay is the default status. Cool. That's it. I run it. Rails S. All right. Can I make a post request to the login route with this username and password? Yep. Somebody didn't like. Maybe I blew out that. Oh, I know what I did. Find by username, params username. All right, if I run that, I get a token back. And that's step 2. What questions do you have?
On that
Mine's-
secret that you did, you can just, I kind of missed that part. You can put anything there.
Yeah, there's good reasons to not just put this in your code base. For example, if I push this up to GitHub, cool. Now you can make your own fake tokens for farmtown.com. But it is just a string ultimately.
Previously, you had it like set to something different than that. It was like a path to something.
Rails.application.secrets.secret.key base. That's an auto-generated one that comes with your app.
So if you push this up to GitHub, though, would that put it in like a git ignore file, like folder or anything like that, where it would protect it a little bit more?
Good question. I don't actually know how that works. I know that they encrypt it so that you can't actually see the string directly. You can only use it in the app. And I'm almost positive you can push this up to GitHub and it'd be fine, but I don't know why. So I'd recommend looking that up and reporting back tomorrow.
Cool.
I know that in production, like you don't go off of that. You make up your own and put it in what's called an env file. And
Okay.
that doesn't get committed and doesn't get pushed up. And
That,
like
that's also like what you would use to, like if you have an API that you're using, you would put your key there.
exactly. And so then somebody new joins your team, you send them a secure email that has that shit. Or if you're like the other 99% of companies, you just Slack it to them.
Gotcha.
But yeah, it doesn't go on GitHub.
Cool.
What else?
What are common like missteps? Because like mine's currently not working, so I'm just kind of curious about the best way to trouble.
What's the error that you're getting?
Malformed request.
Ooh. Most likely, actually, why don't you screen share for a sec?
Okay. So here's my error.
Cool, beautiful.
Here's what I'm sending.
Oop. Take a look at that little X. It's telling you what you did wrong.
Oh, is it because these aren't strings?
JSON, it's not JavaScript. Oh, and it can't be single quotes either. Has to be double quotes.
Oh, okay.
That is a JSON law.
Oh, so now I'll wait the things in the way. There we go. Still got malformed request.
Oop. So we're making a post request to localhost 3000's login path. But if you go over to preview in your body there, take a look at what you're getting. Oh, weird. I haven't seen this. Oh, it's because it's HTTP. Well, no, it is HTTP. Localhost always is. Weird. Okay, copy that line. And we're going to go into your text editor. And in the config, under the environments folder, go to development. Cool. And really just about anywhere in there, paste that line back in. Yeah. And kill your server and restart it. All right. Now try sending it. Hey, out of curiosity, Jason, go back over to your terminal. Do a Rails-V. Oh, did you pull mine down?
Yeah.
Oh, that might be why. Do RVM use 2.6.3?
I did that. Yeah, it took a while to get that to be set up, but I did do that.
Cool. Now do a bundle install, because your gems are different for like every version. All right, cool. Now run that same command, Rails-V. Okay, this might be a Rails 6 thing. But why am I not getting that? What am I using? Rails-V. No, I'm using the same one. That is weird. Let me see that error again. To a blocked host localhost. Blocked host localhost on Rails 6. Yeah, it's a new Rails thing. Okay, go back to your text editor. Okay, why don't you Rails application configure do? I kind of wonder why that didn't take. That looks right. Config.hosts, shovel in, localhost. Okay. All right, so this is saved. Kill your server again and then run it. Okay, back to Rails. Fire it off. Okay, it's not you. Don't worry about it. It's a Rails 6 thing. Pull up your controller real quick, and we can take a look at it together.
This one?
Yep. Back up. All right.
So the only thing I did differently was I didn't do all the knots. So basically, it's the inverse.
So wrong call. Do the knots, and here's why. Generally speaking, you want the last thing to be the happy path. So that as I'm scanning your method, I want to be able to look at the bottom and see what's supposed to happen when everything goes right. Otherwise, the thing that happens right is in the very middle of that method. Much harder to find. But otherwise, that looks pretty good. Other questions? Cool. Let's take 5 minutes, and then we can talk about FP a little bit. So 5-minute break. I'll send out a new link, and thank you for coming to Auth Part 2.